If you have any questions, he is welcome to hear your questions during the talk, so you don't have to wait. But because it's recorded, raise your hand and I'll bring the microphone to you.
Hello, everyone. Hello. One more time. Hello, everyone. Hello. Yeah, much better. Enjoying the conference? Yes. Excellent. So here's the thing. Today I want to sell you on an idea. On the idea that tools are essentially software engineering and that they should be moldable. I will be demonstrating what that means, but I would like you to engage with me if possible. I want you to be as skeptical as you can and challenge me as hard as you can. Is that okay? Okay, good. So, my name is Tudor Gîrba. I work at Think. That's a company that I co-founded. It's a consulting company, but our real goal is to change the development experience. That is the experience that people have when they work with software systems. Notice how I don't necessarily say developers, because I think that everybody that works with a software system should be integrated there. And so when we talk about the experience, we talk about an IDE, right? And so this is a typical kind of an IDE, right? Anybody familiar with that? Good, right? So this is one of those, and here's another one. And what's interesting about them is that it's hard to distinguish between them, right? If you squint from afar, it's not really easy. They're very much similar. And here's maybe another one. So the question here is this the pinnacle of design? And if not, why did we not evolve over the last 20 years? And so is it possible that perhaps we're asking always the same question and that prevents us from evolving? So I'm going to suggest that this is true. So again, before we dive into the actual new proposition, I would like to frame the problem slightly differently. So here's the thing. All of those tools, they are called integrated development environments. And whenever we talk about development, we think about the construction part, the empowering part. That is, I don't have it, I develop it, and then I have it, right? It's very empowering, and this is amazing because we're developers and we're just everything around us gets completely reshaped because of us. So that's an amazing thing to think about. But at the same time, if you look close at what developers do, developers actually don't develop most of the time. And that's an interesting thing. So for a lot of the time, 50% or more, according to different studies, and from my conversations with about 3,000 developers so far, developers spend 50% or more of their time reading code. Would you agree with this? Right? Now here's the other thing. Could you keep your hand up, please, if you agree with this? So if you do agree with this, right, this is 50% or more of the time. This is the largest, most expensive activity we have. So when was the last time you heard developers talk about how they read code? Right? It's amazing, right? Very few are still hand, right? And even if you did hear them, keep your hand up if you've heard of a very regular conversation, or did it just happen last year or half a year ago? It's not a subject of conversation, right? So few hands are, which is great, but in general, it is not a subject of conversation. Thank you. So that was your sports for today. So what is the problem with this? Well, again, this is the single largest expense we have, and nobody talks about it. And I think we should. Now, if you do talk about it, then in fact, most of the time, the reason developers read code is because they want to understand what to do next, right? They want to understand how to make a decision. It's called decision making. So the activity is actually not reading; the activity is decision making. So perhaps, given that this takes most of our time, perhaps it's actually useful to start regarding software engineering as being, less of a construction business and more of a decision making business. And so, if reading is the strategy, then perhaps there are other strategies, right? Because it's this would be the strategy with which you extract information out of data, because that's what you need to make decisions. It so happens that reading is actually the most manual possible way in which you can do that, right? So then why are we not constructing a different perspective on this, given, again, that this is the largest expense? So the first thing we should do every time we want to talk about something is we have to give it a name. So I call it assessment. And I think that's a core activity in software engineering, and we should actually explicitly talk about it and learn from each other in doing that. Okay, so that's the perspective from which I want you to look at the demos that I'll be giving you. So I'll be showing you Glamorous Toolkit. That's a new kind of a development environment, which we call it's a moldable development environment, and I'll explain what that is. Glamorous Toolkit is an environment that is built in Faro and at the moment works for Faro. Anybody knows what Faro is? Wow, surprising amount. So Faro, for those that don't, Faro is a beautiful object-oriented language, is a small-talk system, and it comes with its own environment, a language plus the environment. What Glamorous Toolkit is a replacement of the environment. It's a complete new graphical stack with complete new kinds of properties inside that enables new workflows. So, as I said, I don't want to focus so much on how we construct systems. I much more than spend the time today to look at how we reason about the existing systems. And in order to change bigger patterns, I wanted to start from the cell. So, given that, for example, in this case, we are looking at an object-oriented system, but also in other cases, the smallest possible thing, the most basic thing that we have is perhaps not computation, but data. Right? And in this case, in an object-oriented system, it would be an object. So if you look at typical IDEs and how objects are represented, so when you open an inspector, for example, you see something like this, right? So here I have 6 different inspectors showing you 6 different objects. And what you see, right, they're all represented in the same way, variable and value. Right? That's a reasonable way to look at this, right? But it's only reasonable if the thing that we want the inspector to be is to be something that shows accurately the interior of that object. But most of the time when we want to work with an object, we don't necessarily care how it is represented internally, we care about what it means for us. It's a different perspective. So what if I take those things, this representation works equally well for all objects, that's why all inspectors in the world basically show it. The problem is that most of inspectors in the world today stop there. But let's imagine I have these objects and I change it like this. How does that make you feel? Did you feel something here? No, seriously. Did you feel something? It's the same thing, right? It's really literally exactly the same objects. These two are the same objects. Do you feel how your brain completely changes how it engages with those things? They are boring things otherwise, and immediately they change their nature just because we changed the shape. We molded the shape into something that is more comfortable for your brain, and all of a sudden you could engage, it changes the way you engage with the same problem. So that's actually an interesting thing, because here these are not pictures, these are actually live inspectors there. And when we look at them, they look like this. Right? This is a really living system, and you're looking at an actual object in that living system. So what you see here on the left, you have a fraction, and then we have a color, and then there we have a folder, there we have a picture, there we have some sort of an algorithm showing us the neighborhood, finding the next neighborhood circle, and then here we have a data structure of the internal representation of a piece of text in a text editor. Okay? So completely different things. They should look different. So that's the core property. Yes, we have a question here. Thank you very much for being so skeptical.
I'm not skeptical at all. It's awesome. I was just wondering about the string.
Yeah.
Is that some sort of why is that represented as a tree like that?
That's a rope data structure.
Okay. Yep.
Okay. So a rope data structure is one way to represent text in a text editor. And in fact, you can look at it like this. This is a string representation of it, and this is a textual representation. This is how the text actually looks like when you render it. And this is the data structure behind that text when you look at it.
Very cool,
right? Thanks. Different perspectives on the same thing. So let's do something with this, right? So now here, what I have here is something we call a playground. I'll just show you a kind of an exploratory thing. So let's say that I need to go and look into my file system. So I'm just going to start from my local folder. So I'm inspecting a folder. So now what do I see here? Instead of seeing this, which is, again, this is accurate. It's a completely an accurate description of what is inside that object. But this is useful. So, so because I have this distinction, right, there's the inspector, what I showed you here is that I show you an inspector that have, first of all, different views. Every object, every individual object can be perceived from different views depending on the context from which you want to look at it. So that's one. The second one is that I'm showing you connected objects. So here I executed something, and I'm showing you the resulting object to the right. The other thing, the other third operator here, is that when I select something over here and I dive into that, it's basically the same thing. So here, navigation, so clicking and executing code, they are the same, they are equivalent. Right? Which basically means that there is no necessarily a distinction. When the user interface stops, I can continue programming. In fact, we look at the IDE as a language too. An IDE is not a set of features, but is a language made of visual and interactive operators that basically can extend the host language. So let's see what else can we do here. So here I have a text file, so obviously I can see a preview of those contents. And here, for example, I have a JSON. So I can look at this JSON as I'm just looking at the contents of the file, but because it's JSON, I can look at it like this. And now this is an actual editor here, so I can go and change it. Now remember, I'm in an inspector. An inspector was supposed to be the smallest or most basic tool that you have at your disposal. So now, you see, I already see here, this is a JSON, and there's an array over here made of some elements, and I just don't know how many of those there are. So what could I possibly do? I could potentially go and scroll here, right? I could do that. But this would imply now that I'm going to read my way to finding out this answer. And that's a highly unsophisticated way, it's a highly manual way, and we should go away from doing that. So instead, because this is JSON, JSON is not a text, right? It's super highly structured data. So why not, treat it like that? So here, for example, I open another playground that just works within that context. So for those that are maybe not familiar with the Smalltalk system, it's like a REPL that you apply, that it's where self is this object that you have there. Now, because we already have a JSON parser, I can just type here, I want this parser, and I say I want to apply this parser on the string, and now self is the file, and if I say contents, it will give me those contents. So now I'm parsing that, and I get an object. So now I know there are exactly 9 items in my array, right? And I can continue now navigating like I've done, right? So even if my user interface maybe was not exactly complete, I could still patch those things with a little bit of a code, and then I continue navigating. There's just a continue. There's no boundary between, the perspective of even of a user and that of a developer. And that's also the core of a Smalltalk system, but we are taking it much farther because we now extended with a language, a visual language for the IDE. Now, of course, because we know that this is a typical activity, this JSON from string, applying it to contents, we actually have here a little icon, right? So I can actually click on that one. It already has that same ability, right? So as I learn what I want from my environment, the environment grows too. So this is one thing that we could do. But here's another one. It seems like here I have a couple of folders. And I just want to have a quick overview and see how deep those folders are. I don't know. So one way to do that would be I could just build a map here. So I can just say, let me just, I'll just open an object on which I could just draw something. At the beginning, I don't draw anything. So I just want to look at the data structure or the folder structure, for example. So I'll just say here, I want the nodes, starting from this folder over here. And I want to show in that folder all folders. And so now when I execute that, it's not all folders, it's all directories. Now when I execute that, I get these things. So there are not that many actually, but let's see how they are organized. And so I want to create some edges now, and I'll just connect each of these ones from its parent. So once I do that, I start to have some little lines there. So maybe I will arrange them slightly differently now. So now I have a tree, and then I can continue. But what's interesting about this is that this is not a picture. Right? So if I now click on one of those, I actually go to where I am. So the tool can evolve with me. It is not a dead end. Right? So, question so far. So here's an XML, right? I see that I have an XML over here, and if I go into it, again, I have, it's a small catalog of books with authors and titles. And let's say that I'm quickly interested in just finding out what are the authors that I have in there. So again, what I do is I look at the XML, but that's not a piece of text. It's highly data structured, although you might not necessarily like it. It's still highly structured. Quick question. How many of you love XML? Okay, good. So, yeah, but we can still parse it, right? So I don't have to like it, but it's a data structure, and I want to treat it as if it's a data structure. So now I'm going to go and I see a tree in there. I don't see a piece of text. So I can still navigate there, but it's still clumsy. So what I would like to do is I would just like to go and pick only the author elements from this tree. So what do I do? If I have an XML and I just want to find some tags out of there, what would I do? Sorry? XPath, right? So here, obviously, because we have an element, I could just say here self XPath and maybe say /author. And when I execute that one, I get 12 elements. But that's, that's interesting. I could do this, and I could maybe, but the thing is, I can't map this one on I cannot map this one on a button. I need to map it, because I need an input, I need a string. Right? It's not just a unary execution. I need to pass in the parameter. So in fact, what I would like to do is I would like to extend these ones. So maybe here I should get a new place where I can put that thing. So what I will do now, in order to do exactly that, I will now switch to the meta tab. So the meta tab gives me the source code. It's a browser for the object that I'm looking at. And then if I go somewhere, and let's say that I'm looking for XPath something, and I think it's probably in Node. XPath should be right. Right. So somewhere here, there is this method which is called GTXpath4. So this is actually, I already implemented it, right? So notice how I have here this self XPath whatever. It says it has a button over here with a certain icon, and I want to apply this button on a text editor. So now what I want to do is I want to say, I want to now just annotate the object with this idea that you now can present to me a new widget. So now if I execute that one, the magic tab appeared over here. Right? It didn't exist, and now it exists, and now it's an editor, so I can now write here /author, and when I run this one, I get exactly that. So what just happened here? While I was working with the tool, I noticed that I want to extend the tool, and I take a little few minutes, and then I extend that tool and I continue. Because the way we look, the way objects and everything around our software system, the way those look, they determine the way we're going to think about them. And that's the premise of moldable development. So now if you take a step back here, what kind of a tool is this? Right? Is it a file browser? Is it a visualization tool? Is it an editor? Or is it a query tool? Right? It's all together. There is a question there. But this idea, what I wanted to show here is that there are no tool silos. Tool silos are just an arbitrary artifact that were produced by essentially by tool vendors. And I think that's a wrong way to look at this problem. Yes?
Oh, thanks. How do I get sharing the change I just made to the rest of my team?
Oh, I will commit it to Git, and then the next build will just construct me that view.
And can I still see or reject parts of the commit?
Sorry? So
let's say it's not the only change.
This piece of code goes together with the rest of the source code. And if I have it, and I can put it together with the rest of my system, or I can put it in a different package, or whatever I want, I commit it to Git, and then whatever I assemble, I assemble. Right? Does it make sense? Does it answer the question? Okay, cool. Other questions so far? Okay, so let's go to something. So far I just showed you some technical things. So I want to show you a couple of case studies because we're using these tools already in real life situations. In fact, we've been developing those for about 4 years now, and this is the second generation of the Glamorous Toolkit, and we're already using Moldable development since about 5 years or so. So there's extensive experience that we have with this, and we went through many case studies. So this is the most recent one. Polypoly is a company at which we want to change the way an end user takes control of its digital shadow. So this idea is that your data is now dispersed throughout all of these services, and they basically control your data, and you don't really have access to it. But it's interesting that in Europe, right, with GDPR, GDPR forces vendors to actually provide you the data. So here's actually, we have this idea of a pod that basically lives on your machine. And in this case, I'm showing you an inspector over that pod. And this pod, basically here I have a few accounts. So I see Tudor Gîrba on LinkedIn and Fincom, that's the company account on Twitter, Gîrba on Twitter, and Tudor Gîrba on Facebook. So these are different accounts. And what's interesting about them is that the source code that comes, so the data that you download, you have to go and request your data, you download the data, and at some point it basically looks like this, right? So if I look at the Twitter, and I see something like that, and that's I'm familiar with because it looks like a Twitter feed. But at the same time, the raw data, the data that you actually download looks like this. So maybe here's the contact information or the different tweets. So they actually look in this way, right? So this is actually a JSON wrapped in a JavaScript. I don't know exactly why, but that's what you get, right? So again, this is compliant to the law, but it is not understandable for a human brain or for a regular human brain. So because it is not understandable for us either, we translate it, right? So again, it's the same thing, but now you look at it differently. And so this ability to introspect and go quickly and then change the perspective is super important, especially in these kinds of cases. And development is filled with these types of cases, right? But you have to jump the meta level very quickly. And what's interesting about this is that, again, this is a detailed representation of the data, and we need this representation. But at the same time, this is a user perspective on the data, something a normal user would understand without any kind of knowledge about any technical details. So what's interesting is because why do we have to have this distance between a developer who also happens to be a human and other humans that are not necessarily developers? Why can we not bring those together? And would this not address the problem of communication? Right? Because communication problems are generated because of differences in perspectives. But if we make those perspectives apparent, the conversation completely changes. So this is one of those cases in which we can use this. And so where the exploration part is really, really critical. And what's interesting about this flow is that actually we're spending the largest majority of the time, the development time, in the inspector and not in the code browser. So we literally develop for the most of our time, not even in the debugger and not in the static code browser, but in the inspector where the presence of self, where you always have a self. So that's one. But I was talking about integration at the beginning, and I said that integration is not necessarily something that should only include developers. So here's a different perspective. Like we thought, how do we integrate non-developers? So non-technical people, not just maybe users or so, but non-technical people that understand business. So one of the things that or the mediums that get exchanged or that basically bridge the gap between technical and non-technical people are documents. So here we have a different kind of a document engine. So I want to explain to you how we implemented some prices. So you saw there's a markup language here, a markdown kind of thing, markup language. It's not markdown. And this editor basically makes the markup disappears as I work with it. So let's say that I want to take an example, and I want to just describe to you, this is a financial detail about how do we apply discounts onto prices. So what kind of design did we put on that? So what I will do here, I'll just open a piece of code, and I will say here I want to have 100 euro as price, and as I type, notice how these buttons appear, right? There was no edit mode, and when I run it, I get an inspector over that one. So I have here a concrete price. So again, this already exists. This whole code runs. This is a real IDE running. There is a real system behind it. This is another one. So here, let's say I want to discount this one by 10 euros, and if I execute that one, I'll get a price discounted by money. So this is basically like a decorator pattern. How many of you are familiar with the decorator pattern? Okay, so yeah. So basically, this is another object that wraps the original one and applies the discount, right? So like a functional decomposition there. So let's apply another discount here. So if I say discounted by 10%, I get 81 euros, exactly what I expected. So now let's imagine that I want to communicate this, because we think that, you know, software, like we saw in the keynote from yesterday, software, like the only truth, the main truth is in the code. But the code shows you facts. It doesn't tell you reasons. It doesn't tell you why it is like that. And why it is like that, why anything is, the way we share it as through our culture is through narratives. We want to tell stories about about the things that are less easy to understand. So that's what we think the IDE should be a platform for storytelling too. So here I want to tell you a story, but now it's a little bit difficult because now I want you to tell the story of how this is actually created. So now, of course, I can go here and say discount percentage, and it's applied to 90 euros, which is the discounted by money, which is 10 euro applied to the 100 euro, which is over here. Right? So I could go and navigate from that thing, which was just top down. I go up left to right. But now I lost the context, right? So it's a little too complicated. So now let's compare this one with this view over here. Right? So this view now basically tells me, it gives me that same object, right? But now I present it differently. So I have an object over here, which is 81 euro, is 10% off of 90 euros, which is 100 euros minus 10 euros. Okay? Now again, this view only exists for this object. This is handcrafted for this specific object. But the interesting thing is that the drawing here was drawn by non-technical people on the whiteboard. And once they drew it on the whiteboard, it belongs not on the whiteboard. Once a human deems a representation of a fact as meaningful, it's the responsibility of the system to carry it forward. Okay? So yeah, we can go on like this, but so another thing here actually is that I don't want to write any code into my documentation, because then I have to deal with this idea of how do I synchronize the code between the real code and the documentation, and so there's a whole set of problems. But now I actually wrote this code, so that was an example that you saw there, and now we're also using these examples. Because it's like these are like tests, but they return an object. So here what I want to say is I want to just summon that example, and I want it to come over here. And when I type, and notice how there's no edit mode. As I type here, the code is summoned and comes there. And so now I can execute that code and I can get it there. Right? So I transform my live document becomes live as I type through it. So maybe I want to say that I don't want code at all, and maybe I just want to say that I just want to have a preview just to show me one of the tabs. So I just want to show the overview tab. And as I move away, I'm left with the live document. Right? It's just a document that has no technical detail that I can just ship to non-technical people. And what is interesting about this is the cost of this document on top of after the normal development is very, very small. Right? So here's an actually, how this one would look like for the actual domain. So these are the prices. This is an actual system that we implemented. These are prices that I showed you. And I'll just show you briefly This system also has a workflow system that you have in there. So here, for example, we have one of these. It's a cozy corner over here with a kitchen and a guest room and some actors. And basically, we model them as being actors. And so then we want to see what happens when somebody places an order. So in this case, a user, Alice Guest, placed an order over here, and then it propagated all the way to the cook. And so I'm still in a document, but here there's a to-do item, and if I click on that to-do item, what happens is that the message propagates further, right? So I can learn. It's a live documentation. It's a real documentation of a real running system, but done with the live documentation. And the interesting thing is that the same idea of moldability can be applied to other things, such as search. So here, for example, if I look for a class, which is object, I can see it here, or maybe I look for other things. So I can see multiple of those. So that's an interesting thing. Let's say that I'm interested to search for do, which is a method that for traversing. And maybe I just want to look for the implementers of that so I can see how many there are. But maybe I don't want to look for do in general. I want to look inside the collection because I know that something is there. So now if I dive into the collection, now the scope of the search changed. And so now when I look for do, it will only give me the methods. It will only give me the methods from the collection class. Right? So the idea here is that not only does an object know how to present itself in many ways, it also knows how to search it, how to get search. So if I apply this one to a domain, so here I get my pod, this thing that we're implementing for the different accounts. Right? So if I look for Toolkit, I can see the different kinds of posts. So this comes from Gîrba, and this comes from a different account. This comes from Twitter. So what's interesting here is that now I'm searching through multiple of those. Right? And again, in the same interface, but I can equally maybe just go back and I just say I will just go inside this one, and if I now search for Toolkit, I will only get the searches from that account, right? So the search is also scoped, and it's very simple. What's interesting here is that these are just some examples, right? I didn't handpick. I handpicked those, but out of many. So the idea is that if I take a string, for example, and I inspect that one, and I see a presentation over here, this presentation, and I'll click on to see the implementation of that view, right? This is the method that I created before to implement this view over here. So this method is annotated with GTView, right? So let's quickly find out how many of those do we have. So if I say GTView over here, and I'm looking for the pragmas, which is the name of the annotations, I can search for that, and as I search, I should get a browser in which I can go and navigate. So this is an actual editor in there. But let's quickly find out how many there are. And so there are 725 right now, right? So now quickly find out how many lines of code they all have. And I have here 8,700. So if I do an average now, so I get this GTView and the GT pragmas and the size here, what I get is 12 lines of code, of which one is a signature and the other one is an annotation, so 10 lines of real code. That's the cost of a little plugin. So I have 700 different plugins running at the same time in this IDE, in the demo that I'm giving you. So the idea here is that every time we talk about tools, I think we have to talk about tools, and every time we talk about tools, we also have to understand what Marshall McLuhan and his students warned us from last previous century, and that idea that was summarized by John Culkin, that we shape our tools and thereafter our tools shape us, right? And what follows there is that we have to be very careful with the characteristics of the tools that we expose ourselves to, because they will determine the way we're going to think. Tools are essential in software engineering, and they should be moldable. Thank you very much.
We have a few minutes for more questions, if you have. Yep, one here.
I have one here. I was wondering, impressive technology and interaction. I was wondering how, if one could isolate this interaction and all the comps that you said from the underlying language.
Yeah.
I think it's a complicated problem, but it would be nice if I could write multiple languages and getting the same kind of feeling,
Yes.
right?
Yeah. So Glamorous Toolkit is actually a platform. I'd be very happy to show you that, but there's much more than meets the eye. There's actually already a software analysis platform in there that deals with already many different languages. There is also extensive parsing abilities, and we will definitely target other languages, yes.
So this looks good for visualizing different kinds of data, but often when I'm reading code, I'm not necessarily trying to figure out what's the data I'm working with, but I'm trying to understand how does the algorithm work and what's the process I'm going through. Does Glamorous Toolkit help with that portion of trying to understand code?
Yeah, so the way we work with it, and again, Glamorous Toolkit is the tool, but what's interesting is moldable development, which is every time you replace manual labor with some automation, the real benefits come from when you replace the way you think. And so the way we work, the way we reason and build these kinds of views, right? You saw there are 720 something views, right? So those 720 something views, and if you download Glamorous Toolkit, you have about 400 something, which means that about 250 of those are system specific. So the interesting thing here is that when we work and we have a problem, we don't just solve the problem, we don't just write a test and solve the problem, we build a tool, write a test and solve the problem. And so now where is the problem? So if I have an object that is now telling me or encapsulating an algorithm, and that becomes very interesting because there's a very interesting dialogue between the tool, because I sometimes want to explain something, but when it's not first class, it's very difficult to explain. So then I very often find myself having to go into my algorithm, make it first class, often maybe approach it through a functional decomposition, even if I'm in an object-oriented language. We work a lot with first-class objects, and then you represent a step in that algorithm like that. Or so, for example, I show you this workflow, right? That was a one message, so we reified the message just because we wanted to show you how the message propagates through the different actors. That was an algorithm. So this is how it works.
Thank you very much again, Tudor.
Thank you.